Right then, chapter 23, higher course, page 341. It's section 23.1, actually, the first chapter. Arcs and sectors. Bit revision then. An arc is this small part of circumference, so that little red bit, if you can see it, is called an arc. As you know, that's the radius from the centre to the edge of the circle. And the sector is this area shaded here. Now we're going to work out areas later on, but in the first instance we're going to work out some lengths of bits of circumferences, otherwise known as arcs. So the arc length. Clearly, the bigger the angle made at the centre, the wider the wider the angle, the longer the arc is going to be. Clearly so. So if this was like just a small little slice there, say, I don't know, maybe 20 degrees, then the arc length there will be smaller, won't it? Yeah. So we've been asked to work out the arc length from there to there based upon an angle of 100 degrees with the centre. So we just get rid of that little discussion there, and we do it straight away. Now, clearly circumference is 2 times pi times r. I don't really like pi d very much. I do prefer 2 pi r myself. But clearly we're not working out an entire circumference. We're working out a bit of a circumference or an arc. So essentially we want this fraction of 360 degrees. So 100 over 360 is a fraction. It's the fraction of the entire circle circumference. So it's this fraction of the circumference, which is 2 times 3.14 times the radius of 5. Alright, that's all there is to it. That part is the circumference bit, the entire circumference, and the 100 over 360 is that fraction of the entire circumference. And all we have to do is to put that into the machine. 100 over 360 multiplied by 2 times 3.14 times 5. That gives me 8.7 centimetres. Okay, 1 decimal place is good enough. And the arc length is therefore 8.7, as we said. Just chop that one out of the way and go back to the next one. Okay, what we've got here? Well, look very carefully. We've got a diameter of 20, so straight away better say that the radius is 10, just in case we make a mistake and substitute the diameter in instead. Now, obviously, this is going straight through the centre of the circle, so this is a diameter, and therefore we have half a circle shown there. So this arc is really just half the circumference, and so let's just do it like that. So here we go. The arc length is going to be a half of 2 times pi times the radius of 10. So why is it a half? Very simple, because from there to there, all the way around, we have an angle of 180 degrees over 360, and of course 180 over 360 is a half, times the 2 times the pi times the r. And of course we can punch either one of these into the calculator and get the same answer, because 180 over 360 is clearly half, because we have half a circumference displayed there in red, and of course the other half in black on the other side. So I'm going to go for a half anyway. So 0.5 times 2 times 3.14 times the radius of 10, and that gives me 31.4. Okay, so 31.4 centimetres to 1 decimal place is that arc length all the way around there. Alright then, last one before we move on. Just do that, chop that out of the way, hopefully just we won't crash into the video section at all. Right, what we got here? Now, careful, we've got 90 degrees on this side, but the arc is this red part all the way around here. So this is 90 degrees, then going round this way we have 270 degrees, obviously 3 90s that are left over are 3 90s, which are 3 lots of 90, which is 270. So effectively we have 3/4 of a circle. In other words, 3/4 of a pi. Sorry, not pi. We go for 2 pi r, don't we? So we have 3/4 of a 2 times pi times the radius. All right. Now it's 3/4 again, it's just like before, because we're talking about 270 degrees out of 360 times the 2 times 3.14 times the radius, which is 6.7. Again, any one of these two would do, will work fine. And I'm going to put the 3/4 into the calculator, because 270 over 360 is clearly 3/4. So let me just do that. So 3 divided by 4 times 2 times 3.14, that's the pi, times the radius of 6.7. If I press the right buttons, I will get the correct answer. So according to this, I'm looking at 31.6 centimetres around there. Does that seem reasonable? Seems a bit low, I have to say. Seems a little low. Anyway, that's what I've got. That's the end of it. So 31.6, that's the arc length. And again, the arc length is this little red part here. Just label it again 3 times. Arc, arc, arc. Not the black bit, it's the bit that's required to be calculated. Just a fraction of the circumference anyway. And that's the arcs sorted for you. Very easy. Next little bit. Here we're finding the areas of the sectors. It's been wonderfully shaded for us. It's beautiful. Now you know the area of the circle is pi times radius squared, and just like before, where we wanted to work out a part of a circumference based upon the angle at the centre, we're going to work out now the area of part of this slice of pizza. So this 100-degree slice of pizza will be a fraction of the entire area of the entire circle. So it's the same routine. It's going to be 100 over 360 times pi times the radius, which is 5 centimetres, but it's squared because it's pi r squared, as you know. So that's basically going to be, let's just rewrite it so you can see me show the pi. So 360 times 3.14 times radius squared, 5 squared. Just punch this into our machine. 100 over 360 times 3.14 times, well, 5 squared is 25, so I'll just put it in. 21.8, so 21.8, and being an area, we're looking at centimetres squares worth of pizza. So all that area there is 21.8 centimetres square. Here we have half a circle again, still based on A equals pi r squared. Again, be very careful. We've been given the diameter, and therefore the radius equals 10 centimetres. I could write it in yellow because it sort of shows up better against the red background. So what I want to do is just work out the area of this sector there. Is that okay? So I've got half a circle, clearly so. So it's going to be half times 3.14 times the radius, 10 squared. Alright? So 0.5 times 3.14 times 100, isn't it? Dead easy. I've got 157 centimetre squares of pizza. So it's half the cake, half the pizza. Again, like before, just separate this off into nice little black bits here. That. Now we'll do C in the corner at the top, and then we'll stop, have a little breather. Right, what we've got here. Again, if that's 90 degrees going this way, all this is going to be 270 degrees, all adds up to 360, essentially 3/4 of an entire circle. I like to think of it as pizza because I really enjoy pizza. So here we go. Again, we're still playing with pi r squared. You don't need to write this down every time. I'm just reinforcing it's based upon the area of an entire circle. So what do we got then? We've got 270 over 360. It's that fraction of pi, 3.14, times the radius, which is 6.7, and that's going to be squared. Of course, we don't need to simplify this. We know it's 3/4 anyway, because it's 270 out of 360. So it's 3/4 of 3.14 times the radius, 6.7 squared. And let's just do that and move on. So 3 divided by 4 times 3.14 times 6.7, that's just been squared. Bam! 105.7, there you go. 105.7 centimetre squares to 1 decimal place. And I think I'll stop there. Quick revision, quick recap, quick plenary. Right, a bit of a circumference is called an arc. So therefore our calculations are based on 2 pi r, which is the circumference of the entire circle. And whoops, wrong way. And a bit of an area of a circle is called a sector. So we're based upon A equals pi r squared. So we're working out bits of area of an entire circle. And now I'm going to stop. Thank you. Catch you later.